Right. IP addressing. You see, the IP is a protocol. IP, when we say IP, we really don't mean this number. No, this is IP address. I agree, but this is the IP doesn't mean always the number. It means protocol. The protocol name itself is Internet Protocol, IP, Internet Protocol. And this IP address is used by this IP protocol. That is why it is called as IP address. This type of 32-bit address, is this 32? Yes. Actually, we have written it in a decimal form. But in the reality, it is bits. So this 32-bit identification is what IP protocol uses to identify a device in a network. Any device in a network, it can be a laptop or a router or a firewall or a cell phone, or any device in the internet is identified with this type of address by the IP protocol. That is why it has got the name IP address. Now, as I said, this is 32-bit, 32 binary bits. This 32 binary bits have already finished, got over, exhausted long back. This 32 binary bits, maybe like 30 years back, before you were born, this was considered as a big address. But today everyone is using internet. So there is no sufficient IP address. We don't have IP address in first place. That is why we also have another version of IP address, which is 128 bits, binary bits in size, called IPv6 address. V6 is 128 bit, which is already there in our network today. This is not a old, so this is not yet to come. This has already come. For example, you see, I'll try to command prompt. I'll go to command prompt in my laptop and I'll trace, or I'll say ping www.yahoo.com. You see, I'm getting reply not from an IPv4 address. Is this IPv4 address? Is it looking like an IPv4 address? No. See how big it is. It is IPv6 address. This proves that we are already into IPv6 world. And why are we learning IPv4? See, we also have IPv4 in some part of our network. So what you learned, what you saw in that video is IPv4 addressing. But you need to also understand we are already in IPv6. Some countries are still in IPv4. Even in India, some part is still in IPv4. But the core internet is already in IPv6 all over India. So slowly the entire world is migrating into IPv6. Even we like it or not, IPv6 is already there. They did not take any permission from me to have IPv6. There was somehow, without my knowledge, I got the IPv6 address in my laptop, and my laptop started using IPv6. Yeah, that is how it happened. Then you will not be aware of that whether your laptop is IPv6 or IPv4. IP address is 32-bit only. Now, with this 32-bit giving entire world, internet is challenging. So what they did is they were trying to use the 32-bit in a very clever manner. Some users will use a few IP addresses, some will use millions of IP addresses. So depending on the need of the customer, we need to give the IP. So what they did is they classified in three categories: Class A, Category B, and C. Class C. Now there is also one more class, D, but that is not for an individual computer. This class D address is not a unicast address. What is unicast? Address that is to identify a single device. See, if I want to talk to your computer, there is an address for your computer. That is unicast address. Unicast address is what you will get in class A, class B, and class C. Then what is class D? Class D is a multicast address. Multicast address. This is not to identify an individual device, rather it is to identify group. For example, all computers inside HR department. To identify all computer in HR department, you can give one multicast address. So any traffic you send to a multicast address will go to that group of people, not to a single people. Like your WhatsApp group. In WhatsApp group, all have got their own phone number. But how can one message go to everyone? Because on top of that individual phone number, there is also another identification that WhatsApp creates. So any traffic sent by you will be sent to that group ID, and all the members of the group will be receiving that address. Traffic, the data. So multicast is not our focus. But just for your knowledge, I am writing multicast address is class D range address. And this multicast address will be any address that begins with 224 to 239. If you find an address like this 239.1.1.1, it is not a unicast address to go to a single computer or a single device. This is to identify a group of computers or a group of routers. So that's enough as of now for multicasting. Now let us go to our main topic. The unicast address have got three classes: Class A, B, and C. Class A ranges from 1 to 127. And Class B is 128 to 191. Class C is 192 to 223. So when I see an address starting with 200.5.190.128, what class it is, you should not see this number. If you see this number, then you will say class A. No, don't see that. You should not see this also. If you see this, then you will say class B. No, don't see this also. You will say class B. You should only focus on the first octet. It is 200, which means it is class C address. Now, three classes, A, B, and C. Before we come to this classification, let's talk more about this 32-bit. See, IP address is 32-bit, but it's a binary 32-bit, which is difficult for human being to handle. Remember, right? So the 32-bit is equally divided into equal, 4 equal parts, separating them by 3 decimal, 3 dots, dots, 3 dots. So four equal part, meaning I need to break down this by 4. I get 8, right? Yes. So here you got 8-bit, here you got another 8-bit, 8-bit, totally 32-bit. We call each 8-bit with another name called octet. So we have 4 octet. IP address is 4 octet separated by 3 dots. Now, octet is 8-bit. Octet is 4 octet. One IP address is 4 octet, and each octet is separated by a dot. And all this will be zeros and ones, which is not easy for us to remember or reproduce or rewrite it. You cannot rewrite. I'm writing like this, but after writing, if I close this page and ask someone to write, they will not be able to write. Instead of these zeros and ones, if I write like this, 10.200.3 to 32.50, this people can reproduce it. If they can write it, they can recall and write it. Even if I close this page, they can write it correctly. 10.200.32.50, easy to remember. 10.200.30.50, easy. 32.50, easy. But it is not easy to manage, recall binaries. So we convert these binaries into this type of decimal format. So when we write IP address, we write it in decimal. The decimal format IP address is what classified into class A, B, and C. Right? Now, let us try to understand octet first. We'll go to class A, B, and C later. I have 8-bit here. Let's try to understand 8-bit. Because IP address have got 4 8-bit. If you understand one 8-bit, then it's the same thing for other 3 octets. It's binary, so we put 2 to the power of 0 for this place. If it is decimal, what we used to do? See, you remember in schools they might have taught you this. Let me write a big number: 78492. In schools, you might have written like this: 10, no, 2 into 10 to the power of 0, 9 into 10 to the power of 1. You remember in 6th standard? Now, why do we put 10? Because this is decimal. If it is binary, 1101, same 8-bit I have written here. This how you write, 1 into 1 into 2 to the power of 0. 1 into 2 to the power of 1. This is how we write. Why we put 2 here because it is binary. See, this is 10 because decimal numbers are 0 to 9. 0 to 9. How many numbers you have? 10 numbers. Do you have 11th number in decimal? No. See, if I put 10 here, this is not a fresh number. This is a number created by using these two, correct? So, in decimal, the total number of fresh numbers are only 10. That's why you put 10 to the power of 0. In binary, we will put 2 to the power of 0. Right, like this. So this is what I'm writing here, 2 to the power of 0, 2 to the power of 1. Instead of putting this L, no, I'm writing straight away here. You understand now what I'm trying to do? Okay. This is 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. Now, these are the face value. We used to call this face values. This is 0th place, first place, second place. We used to say, ones, tens, 100,000, 10,000, lakh, 10 lakh, crore, decimal, likewise here. 0th place, first place, like that. Now, if I have all the bits 1, we usually used to write like this. We put this 1 here and this 2 to the power of 0 here. And what answer you get? 2 to the power of 0, anything power 0 is 1. 1 multiplied by 1 is 1. So that's what I'm writing here, 1. And then 1 multiplied by 2 to the power of 1 is, 2 to the power of 1 is 2. 2 multiplied by 1 is 2. Likewise, 2 to the power of 2 is 4. 4 multiplied by 1 is 4. 2 to the power of 3 is, what is 2 to the power of 3? Very good. 8 multiplied by 1 is 8. So if you notice here, it is doubling. 1, 2, 2 if you double, becomes 4. 4 if you double, it becomes 8. Then what this will be? 16. What this will be? 32. 64. 128. Okay. So you don't need to write like this again, like putting L and all. If there is 1 in this place, the weightage, the value is 128. If there is 1 in this place, the value is 16 in this place. Okay, now I'm going to write octet here. You need to tell me the value of it. 1 0 0 0 0 0 0 1. What is the value of this? What is the decimal value of it? That is all. Very good. 129. So you added this one and this one, and you did not add all this because anything multiplied by 0 is 0. 64 multiplied by 0 is 0. 632 multiplied by 0 is 0. So you did not add those things. So you're good now. I'm going to give you another one. Now you tell me what value you get. Exactly. 193. So you always remember, if the first two is 1, then it is 192. Okay. Now, if the first 3 is 1, it is always 224 only. Calculate and see. If the higher order 3 bits are 1, it is 224. It is because 128 plus 64 plus 32. Yeah. So every time you don't need to add like this and find 224, you just remember that 8 bit, if the first two bits are on, it is 192. If the first three are on, it is 224. Now, shall I give you some exercise? Will you be able to calculate? No. Before that, let me give you a few more tips. If you have first 4 bit on, then it is always 240. Every time you do it is going to be 240. Then why you need to calculate every time? Because here it is 16 now. So already you have 224 plus 16 is 240. Another thing is, this is another 8 bit here. Then it will be 248. 248. So like this, if you remember, if these three are on, I know always it is 7. How? 4 plus 2 plus 1 is 7. So I don't calculate, I don't add every time. Anyway, you are not going to have more than 8 bit. So it is better to remember this. This is always 15. How? 8 plus 4 plus 2 plus 1. Okay. Try to keep in remembrance. Try to remember this. One 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 0 0 1 1 1. What is the value? Sorry, what did you say? Okay, good. 224 plus 7, 231. Very nice. So next is 11000111. Yeah, 192 plus 7 is 199. Oh, you learned very fast. 11111000. How will you know? Wait, I appreciate you are trying. How I'll do? When all are 1, it is 255, okay? When all the bits are 1, it is 255. So I minus the 7. I know this value is 7. I subtract it from here. Yeah, that is easy, no? Yeah. Or you can also say this is 240 plus 8, 248. Okay, now, shall we do two more? 11101111. How I do, 255 minus the value of this one. 16, right? This place. 255 minus 16. What is the value? 239, right? Let me give you another one. 11110101. You use any method and you tell me. That's all. Very nice. How did you do? Wonderful. 255 minus 10. That is how I also used to do. Okay. Well done. Now let us move on to classes. See, we already understood octet. It's the same 4 times you have octet. Now you know how to convert a binary IP address into decimal IP address, which is needed. This knowledge, what you have acquired now, is needed when you do subnetting. As of now, I'm just uh, taking you to simple classification of IP address. Subnetting we'll see later. Now, in class A, the reservation for network is 8-bit. In class B, it is double. 8 plus 8, 16-bit. Whereas in class C, it is more than that. 8 plus 8 plus 8, 24. So in class B, out of 4 octet, 3 octet is already network. So the only octet for host is, only bits for host is 8-bit, only one host. Only one host. Sorry, only one octet for host. Whereas in class B, for host, 8 plus 8, 16-bit. In class C, it is 24 bits, host bits, 24 host bits. You understand? Okay. So in class A address only, we will get many hosts because you got 24 bit. How many you will get? Say for example, in class A, 5 is class A, and these octets are host bits. 24 bits are there. So how many you will get? 2 to the power of 24. Why 2 to the power of? Because it is binary. Why 24? Because 8 plus 8 plus 8. That is why 24. Minus 2. Why minus 2? See, is there any value for 0, 0, 0, 0? No. Likewise, 5.255.255.255 is also not a IP address. This is called as broadcast address. When all the host bits are on, you get 255, 255, 255 here. When all the host bits are on, that is not a valid IP address. So we don't use this one. We don't use this one. That is why minus 2. So if you take just one class A network 5, you will get these million IP address. Let's take a calculator and check how many. Two to the power of 24. These 16 million IP address per class A network. One class A network can give 16 million. இதை போயிட்டு ஒரு 100 கம்ப்யூட்டர் வச்சிருக்கிறவனுக்கு கொடுத்தா எவ்வளவு பெரிய நஷ்டமாயிடும். We can't give this class A range network for a small browsing center which has got 500 computer or a small ISP. One small internet service provider is there for a village, let's say. In the village, there's only 200 houses. Each house you need to give internet. Will you give class A? No, you should not give class A. If you give class A, then he will use only 100, and among 16 million, only 100 is used. All the rest are useless. He won't use. You cannot give also to someone. So, depending on the requirement of the customer, whether to give class A or B or C is determined. In class B, same story, 2 to the power of 16, because it is 8 plus 8, minus 2 hosts. In class C, you know very well, it's only 8 bit, 2 to the power of 8 minus 2, which will be 224, sorry, 254. you'll get only 254 valid IP address. 2 power of 8 is 256 minus 2, it's 224. 2 to the power of 16 is 65536. Minus 2 is 65534. So in each class B address, you will get these many hosts. Okay. You understood how the classification divides the users group. Users group, if it is too small, then class C. If it is medium, like 60,000, 30,000, then class B. If the user is big, like million, like someone who connects the entire world, then that type of business people will be given class A. Yes, you're going to get 16 million. Right. So by seeing the first number in the IP address, you should know whether it is A or B or C. And the range of class A is 1 to 126. Class B is 120 to 191. Class C is 192 to 223. You need to memorize this. You need to keep this in mind always. The range you should know. Okay. So based on this, shall I ask you a question? All right. Now, uh, 193.0.5.2. What class address is this? Okay. In class C, how many bits are network bits? 3 octets. So each octet is giving you 255, right? Each octet, if all the bits of the octet is 1, what is the value of each octet? 255, right? This is what we call as default mask. When you see this, what you understand, in this above address, this portion is network and this portion is the host because it is not masked. Masking means what, reserving for network. All 8 bits are reserved here for network. Here also. That's why you put 255. This we call as default subnet mask. Default mask. So the network identification is 193.05. In that the host, the computer, host is nothing but what is host? Any device which is hosted, which is connected in the network is a host. It can be a laptop or computer or a cell phone or anything. Okay. Now, are you ready for the second question? 171.4.5.2. What class it is? In class B, how many octets are networked? Okay, which means these two are network. So the default mask is 255.255.0.0. It means that what? These two are network. This 5.2 is the host ID. This is host ID. This is network ID. Okay. Likewise, this is network ID. This is host ID. All right. Let me ask you another one. 125.14.3.1. What class it is? So what will be the default mask? Very nice. Only first octet is network, so we put 255 only to the first octet, other or host. So this is 125th network. In that network, the computer is identified with this number 14.3.1 host ID. You understood this network ID and host ID concept? Okay. Right. Next. If you notice here, in class A, I have written one of the number in a bracket. The reason is address starting with 127 is not given to any computer on earth for identification. 127 is not a valid IP address range. Any IP address starting with 127 can be any number in the other three octets. Anything that starts with 127, it can be 127.1.1.1, or it can be 127.5.5.5. Anything that starts with 1, it's not a valid IP address. We call that as loop back address. This is for checking our device whether all 7 layers are functioning or not. For example, you see, I go to my command prompt. I'm pinging something starting with 127. You only tell me 3 numbers. Tell me 3 numbers. It should be less than 255. Okay. Tell me any 3 number. See, someone is replying me. Who is replying? Did I configure this IP address to any of my computer's port? No. Then who is replying me? It is operating system. This is just telling that your OSI layer is fine. Your device is well suitable for network. Only if you don't get reply, then your laptop has got some issue with the network interface card or some driver or something. Nowadays, you won't face problem because nowadays operating system decides the driver and all. So no need to worry about the network interface card driver. You know what is network interface card? The port where you connect the wire to the laptop, or the Ethernet or the Wi-Fi card driver and all. You know, nowadays it comes with the Windows. What I'm trying to say is this 127 address is only meant to check whether your PC is eligible to be the part of network. I'll give another number like 127.80.40.60. That also I'll get reply as if someone is there. There is no one. Okay. So 127 is not a valid range of IP address. That's why I wrote in the bracket. Even though it is class A, it is not a valid IP address. Likewise, we also have 169.254. Any number. This is called as API address, Automatic Private Internet Protocol address. From here, we will see in our next recap class.